Hello everyone, welcome to Pepcoding. Today we are going to solve a question, is spiral display. So let me explain you the question first, then we will look for the answers. So in this question what we are given a 2D matrix. So let me draw a 2D matrix first. 1 1, 1 2, 1 3, 1 4, 1 5, 1 6 and 1 7. 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 2 7. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 3 7, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 4 7, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 5 7. So just suppose this is the 2D matrix and we have to traverse on this matrix in a spiral pattern. So we have to start from this point, then we have to move downwards, then we have to move right side, then upside, then left side, then again down, then right, then up, then left, then down, then right. So this is forming a spiral. So we have to traverse on this matrix on this pattern. So what will be the expected output of this question? So first we will visit 11. After that we will visit 21, then 31, then 41, after that 51, after that 52, after that 53, then 54, then 55, then 56, then 57, then 47, then 37, then 27, then 17, after that 16, 15, 14, 13, 12, after that 22, 32, 42, then 52, not 52, uh, not 52 because we have printed 52 already. So after that 42 we have to move to 43, then 44, then 45, then 46, then 36, then 26, then 25, then 24, then 23, then 33, then 34, then 35. This will be the expected output. Okay, so now what should be the approach for this question? Okay, so if we assume it at like it is a room, first of all it is the outer box, just suppose it is the outer box. Okay, yes, just suppose this is the outer box. First we have to print this border of this box. Just suppose this is the box, this is the box, this is the inside box. After that this one, what is happening? First of all we are printing this side, this left wall of this box. After that we are printing this right bottom side of the box. After that we are printing this left side of the box. After that we are printing the top side of the box. And after that we are moving inside this box and we are again printing the left side, then bottom, then right, then top. Okay, and this is going on. So we got here that first of all we have to print left wall of this box. After that we have to print the bottom wall of this box. After that we have to print the right wall of the box. After that we have to print the top wall of the box. Okay, but in all this what is happening, the corner elements, these are getting repeated. Like if I print this left wall and then I print this bottom wall, what will happen? This element will be repeated, same this element will be repeated, same this element will be repeated. We will manage this. First of all let's go and do this much. After that we will look forward what we can do. Okay, so here, okay, so first of all let's check the input. We have an M. So first of all let's define a scanner. Scanner, Good. This is done. Now int n. Now name variable for the columns. Okay. This is it. Now we have to define an array to store the values. Now we have to take the input of the values. 0 is less than n is increased. Inside this, one more for loop. Okay. Now we'll store the values. Okay. Now we have the values. We have the matrix. Now we have to move on that matrix in a spiral pattern. Okay. So for that, first of all, what we have decided? We have decided that we'll print the left wall, then bottom wall, then right wall, then top wall. First of all, we have to run a loop for printing the left wall, this loop. So for moving on the matrix, we need some references, some elements. That is the number of rows, the columns, something like that. So we have to start from here. Here the rows and columns are 0, 0. So we will define one minimum row, which is 0, and a minimum column, which is 0. And we need a max row and max column to traverse. So we will get the limit of this matrix and we can traverse on it. So we will get a max row, which is n minus 1, and a max column, which is m minus 1. Okay, so let's go and define that. Int max row is equal to n minus 1, int max column is equal to m minus 1. Okay, and one min row is equal to 0, and min column is equal to 0. This is done. Now what is happening? We are going to run this loop to print the left wall, then we are going to run the loop to print the bottom wall, then we are going to run loop to print the right wall. After that we are going to run loop to print the top wall. Okay, but until when we are going to run the loop? Until all the elements are printed. So for that, what we will do, we will take care of that later. First of all, let's simply go inside this while loop. When we have to terminate this loop, we will decide it later. Just suppose this is true. What will happen? First of all, we are going to print the left wall. After that, we are going to print the bottom wall. After that, we are going to print the right wall. After that, we are going to print the top wall. Okay. So for that, first we have to run a loop to print the left wall. So what we have on the left wall? In the left wall, we are starting from 0 cross 0, the minimum row and minimum column, and we are moving to the max row. But our column is constant. The column is 0 only. So there will be no changes in the column, but there will be changes in the row only. Okay, so let me make it full screen so it will be easy. Here. So for int I equals to min row and j equals to min column, but the column is constant, so we will not change the value of j. We will only change the value of I. So until I is less than max row or equals to also max row, we will run this loop and I will be increased. J will be the constant. We have seen that the column is constant. So what will happen here? We will simply print this element system.out.print. Okay, arr nj. Okay, this is done. Our left wall is printed. Then we came to our bottom wall. What is happening in the bottom wall? Let's see. Let's have a look. In the bottom wall, what is happening? Our row is constant, that is max row, but our column is getting changed, getting increased every time from min column to the max column. Okay, so this time our row will be the constant and our column will change. So int I equals to max row and j will be min column, and until the j is less than max column, our j will be increased and our I will be the constant, and we will print this. This is done. Okay, now let's move to the right wall. What is happening in the right wall? In the right wall, we are at the last row, max row, and we are moving towards the min row, but the column is constant and that column is max column. Okay, so here what we will do, for int I equals to max row and j equals to max column until our j is less than or equals to min row. This loop will run. We have to put a semicolon here. Semicolon. Okay, done. Now our I will be decreased every time this time because we are moving from max row to the min row. Okay. Now system.out.print. Okay. Here are I, j. This is done. After that, we come to the top wall. What is happening on the top wall? Let's have a look. On the top wall, our row is constant, that is min row, but we are moving in the columns from max column to the min column. Okay, so our row will be constant. So here for I equals to min row and j equals to max column, and what will happen till the j is greater than or equal to min column, this loop will run. Every time j will be decreased. Okay, now this is the, now we will simply print. Okay, so our all the walls are printed. Now we have to save the corners. We have to save this corner that are printed twice. So for that, what we're doing, just have a look on the left wall. When we have printed from this point to this point, our next loop is getting started from min column to the max column. If we increase the min column by 1, then our loop will start from this point and this element will be saved by printing twice. Okay, so when we complete this point, printing our left wall, we will simply increase our min column by 1. And let's see what happens at this corner. When we print this complete bottom wall, if we need to if we need not to print this element again, what we will do, we will simply decrease the max row by 1, then the next loop will start from this point to the 47 and reach to 17. Okay, so after completing the bottom wall, what we will do, we will decrease the max row by 1. Okay, and now here, after printing the right wall, what we will do, if you have printed the right wall and if you directly start printing the top wall, what will happen, this element will be repeated. But if we decrease the max column by 1, our loop will start from this point and go to this point and this element will be saved. Okay, so here what will happen, after printing the right wall, we will simply decrease the max column by 1. And what for the top wall, after printing the top wall, what we'll do, we printed the top wall, we reached at this point. Now after we have to print this point. Okay, so for that, what we have to do, we have to increase the minimum row by 1. If we not increase the minimum row, it will start printing from 12, 22, 32. This element will be repeated. For saving this, we will simply increase the minimum row by 1, so it will start from 22. Okay, so after printing the top wall, what we will do, we will increase the minimum row by 1. Now this is done. Okay, now we have to figure out when this loop will end. Here, when this loop will end. So for that, just tell me one point. If all the elements of this matrix is printed, there is any need to go on the loop? No, no. So we will calculate the element, total number of element, and if all the elements are printed, we will simply end the loop. So here total number of elements is equals to m into n. Okay, and we'll define a count to track the record, which is 0. Okay, and every time I print is an element, I will increase the count by 1. Here also increase the count by 1, increase the count by 1, increase the count by 1. In all the 4 walls the count is increased. And here also when we start the loop, we will check if our count is less than total number of elements, then this loop will run. Okay, now this part is done. There is one exception here, like just suppose this box is complete, like it have left wall, bottom wall, right wall and the top wall. This box is also complete, it have left wall, bottom wall, right wall and top wall. But what for this? This box is incomplete, it have just one wall, this one wall. Okay, you can say this element is a left wall for this and this is the bottom wall for this, but it don't have right and top wall. So if we print all the walls after coming inside this loop, what will happen? It will repeat the elements. But if we check before printing any wall that our number of elements is completed or not, so it won't repeat the element. Okay, so before printing the wall, we will check if that wall is present or not. How we will check that? Simply we will put the count there also, if count is less than total number of elements. Here also, if count is less than total number of elements, less than. Here also, if count is less than total number of, at this point count is less than total number of elements, then the wall will be printed. Okay, now the code is complete. Let's go run this code and see what happens. Okay, index is out of bound at line number 41. Okay, let's have a look. On 41, what we are printing? Okay, yeah, we have to print greater than or equal to min row. Now let's run this again. Again we are having a trouble on the line number 35. Less than equal to max column. Okay, now let's run this. Yeah, it is accepted. Now let's submit it and see. Completely 10 by 10. Thank you so much. I hope you have enjoyed the video. Please like and share the video and subscribe the channel. Thank you so much.